Srinivasa Ramanujan. It's a name that just echoes with a kind of mathematical mysticism, doesn't it? We're talking about a man with almost zero formal training who could somehow see infinity, who spoke in the language of numbers, and whose ideas, believe it or not, are still unlocking the secrets of our universe a full century after he died. So let's dive in and try to unravel the enigma of the man who knew infinity.
Okay, just a quick note before we really get going. This is a deep dive. We're not just scratching the surface here, we're getting right into the weeds of the mathematics. So if you're looking for more of a general introduction, we actually have another explainer that covers that. Today, we're going straight for the complexity.
You see, the story of his deepest secrets, it doesn't even begin in his lifetime, but decades after he was gone. Picture this. The year is 1976. A mathematician named George Andrews is digging through some old archives in the Trinity College Library, and he stumbles upon this dusty wooden box. Inside, a simple, handwritten notebook. And what he found, it was the mathematical equivalent of discovering a lost masterpiece. This wasn't just some old collection of notes. This was like a final transmission from one of the greatest minds in history, literally written on his deathbed. That notebook had over 600 formulas Ramanujan had never shown anyone, and among them were these mysterious things called Mach theta functions. Back then, they were a complete puzzle, but today, scientists are using those exact formulas to calculate the entropy of black holes, something that relies on Stephen Hawking's work from the 1970s. So how on earth did a man in 1920 write down the math for physics that wouldn't even exist for another 50 years? To understand that, we have to go back. So let's explore the unique crucible that forged his mind. This wasn't a product of elite universities or anything like that. This was pure, isolated genius, and one very, very unusual book. Ramanujan's path was, well, it was just explosive. By the time he was 11, he'd completely exhausted the mathematical knowledge of 2 college students who were living at his home. By 13, he'd mastered advanced trigonometry all on his own and was already coming up with his own theorems. But then, at age 16, a friend lent him a library book that changed absolutely everything. Now, you gotta understand, this was not your average textbook. Carr's synopsis was this dense, bare-bones collection of over 5,000 theorems and formulas, just listed one after another with no explanations, no proofs, nothing. For most people, it would be totally useless, but for Ramanujan, it was like a Bible. It taught him his unique style to focus on the final, beautiful results and to just trust his intuition to get him there. And that intuitive results-first approach would eventually bring him all the way to Cambridge, England, and right into the orbit of a man who was, in every sense, his complete opposite, the brilliant British mathematician G.H. Hardy. These two men could not have been more different. Hardy was the poster child for logic and rigorous proof. He was an atheist who believed that mathematics had to be built brick by logical brick, period. Ramanujan, on the other hand, was a devout Hindu who claimed his family goddess, Namagiri, literally fed him equations in his dreams. He famously said, "An equation has no meaning for me unless it expresses a thought of God." It was a true clash of worlds. At first, Hardy was totally skeptical of the unproven theorems Ramanujan sent him in a letter from India. He almost threw it in the trash, thinking it was some kind of prank. But as he and his colleague J.E. Littlewood started looking at the formulas, they were just floored. Hardy later said this, and it's such a powerful admission from a man who lived and breathed by proof, that Ramanujan's work was so profoundly, impossibly original, it just had to be true. So what did this math actually look like? All right, let's peel back the curtain a little bit and look at the actual language Ramanujan used to describe the universe. Okay, take a look at this. This is one of his most famous creations. It's not just an equation, it's more like a recipe for one of the most fundamental constants in the universe, pi. You see, instead of thinking of pi as just a simple ratio, Ramanujan saw it as this incredibly intricate, infinitely unfolding structure. It looks ridiculously complex, I know, but what it does is just breathtakingly elegant. The real magic of this formula is its speed. It's mind-bogglingly fast. Just the very first piece of that infinite puzzle, just setting k to 0, gives you an approximation of pi that's already accurate to 6 decimal places. It was a totally new way of thinking about pi, not as some geometric ratio, but as this emergent property of a complex series. And that's exactly why modern supercomputers use variations of this approach to calculate pi to trillions of digits.
And that brings us back to his final gift, those Mach theta functions from the last notebook. For decades, nobody had a clue what they were. Seriously, they were like a beautiful song, but in a language nobody could speak. It took almost a century for mathematicians to finally figure out that they're what we now call harmonic weak Moss forms. Think of it like this. If a regular theta function is a perfectly symmetrical crystal, a Mach theta function is like a crystal with a deliberate, beautiful flaw that actually gives it all these unique properties. And it's those flaws that make them so important for fields like string theory.
But his intuitive genius wasn't just a solo act. When he teamed up with Hardy, they tackled the partition problem, which is basically, how many ways can you write a number as a sum of other numbers? The circle method they came up with was this revolutionary way to estimate really complex counting problems. It's a tool so powerful, it's still fundamental to number theory today.
Okay, before we continue, just a quick and necessary disclaimer. We are about to discuss historical medical diagnoses, so please remember this is just for informational purposes and is not medical advice.
You know, the same mind that could dance with infinity was housed in a really frail body. The cold, damp English weather, the incredible difficulty of being a strict vegetarian during World War I rationing, and this profound, crushing isolation, it all took a terrible toll. He was diagnosed with tuberculosis, suffered from severe depression, and even attempted suicide. He eventually returned to India, where he died at just 32. And the real tragedy? Modern analysis suggests the original diagnosis was probably wrong, and he likely had hepatic amoebiasis, which is a treatable parasitic infection. But his death, it wasn't the end. Not by a long shot. The legacy he left behind is so profound that it continues to shape math and science to this very day, solidifying his legend as the man who knew infinity. 1729. At a glance, it's just a number, right? Maybe even a little uninteresting. But to Ramanujan, there was simply no such thing as a boring number. This story here is absolutely legendary. G.H. Hardy took a taxi to visit the ailing Ramanujan and casually remarked that its number, 1729, was rather a dull one. Without a moment's hesitation, Ramanujan replied from his bed, "No, Hardy, it is a very interesting number. It is the smallest number expressible as the sum of two cubes in two different ways." That's just how his mind worked, effortlessly, constantly seeing these hidden, beautiful patterns in the universe. His monumental impact is just everywhere in math and physics. His work on partitions gave us that incredible circle method. His series for pi completely redefined computational power. His Mach theta functions unlocked secrets of modern physics. He was an absolute master of things called continued fractions and hypergeometric series, and his famous conjecture built a bridge between two massive fields of math, number theory and algebraic geometry. But maybe the best way to sum it all up comes from his own collaborator, Hardy. When he was rating mathematicians on pure, raw talent, Hardy, a giant in his own right, gave himself a modest 25. He gave the great David Hilbert an 80. But for Ramanujan, he reserved a perfect score, 100. And that's the key thing to remember. His legacy isn't some dusty museum piece. His notebooks, the ones he wrote in India and that lost one found in Cambridge, are still being mined for new ideas. I mean, mathematicians today are still proving his theorems and finding that little comments he scribbled in the margins are actually profound results in their own right. His work is a living, breathing source of discovery. Which, it leaves us with that central question, the one that really defines his enigma. Was he truly channeling some divine power, just like he believed? Or was his mind an extraordinary, ultimate testament to what human intuition, completely untethered from formal structures, is capable of achieving? That, perhaps, is a problem that even Ramanujan himself couldn't solve.